Alright, this is Precalculus Concept 7b, evaluating functions and a difficult evaluating problem called the difference quotient. We're going to start off with an example here. I'm going to give you a function and we're going to go through evaluating it for 5 different inputs. Alright, so if my function is f of x equals negative 2x squared minus 4x plus 1, the way I'm going to evaluate that is to basically copy my formula exactly, but in place of x, I'm going to put the input value, which in this case is 0. Right? The second term is going to be 4 times my input, which is in this case 0, and then I'm going to finish with a plus 1. Right? I think most of you are pretty good with inputting numbers like this. I would get a final answer of 1. And let's move on to the second one. Alright, very similar example here, except my input is a different number. Be careful about your distributing. Oops, I forgot my squared on the first one. So it's negative 2 times 9 minus 12 plus 1, and that ends up being negative 18 minus 12 plus 1. And that ends up being negative 29. So negative 29 is the value of f of 3. Alright, next example is once again the same thing. You're going to take your function rule. This time your input is negative 2. Be especially careful with negative numbers about order of operations and about distributing. So I should get negative 2 times 4, because that's negative 2 squared, minus 4 times negative 2, which ends up being plus 8, and then plus 1, and the answer of this one turns out to be 1. So it's okay that f of 0 equals 1 and f of negative 2 equals 1. You can have two different inputs give you the same output, but you can't have one input give you two different outputs. Alright, our next example is a little different because instead of my input being a number, it's a variable, but the steps are exactly the same. You're going to take your function rule and your input value, which is in yellow there, it's a letter, and that means that your answer, instead of being a numerical answer, is going to be a formula. So I would have negative 2b squared minus 4b plus 1. And that's as far as you can go with that. So in some ways, having a letter input is easier, but instead of being a numerical answer, it's going to be a formula. Alright, let's look at this last one because this is where people tend to get a little bit confused, but I will give you the hint that it's the exact same thing that we've done for the previous examples. So I'm going to take my function rule, which says negative 2 times my input squared, and my input in this example is a x plus h formula. Right, my next step would be to subtract 4 times my input value, which again is x plus h, and then I'm going to add 1 in the end, and that's my answer. It's not simplified yet, but that is the answer by inputting x plus h. Oftentimes people think of distributing the f. You cannot do that. Some people see this as a multiplication problem. You can't do that either. It's really just a input-output problem where your input is the expression x plus h. Alright, let's work out the answer out here. I'm going to have negative 2. When I square x plus h, you get a binomial squared, and hopefully you remember that formula from your Algebra 1 or Algebra 2. And I get this trinomial, and then when I input x plus h in the second spot, I'm going to get 4x and minus 4h. Make sure you distribute the negative sign there. Plus 1, and my final solution when I distribute everything would be negative 2x squared minus 4xh minus 2h squared minus 4x minus 4h plus 1. So these expressions tend to get really complicated. They do have an important significance when we move on to calculus, so being able to evaluate something like that is important. Alright, let's try a u-try. I gave you a new function up here at the top. I would like you to find f of negative 2. Alright, hopefully you took negative 2 as your input and plugged it into the formula, kept track of all your order of operations, distributing, and combining everything together. You should get negative 8 minus 3 times 4, which is 12, and then minus 4. Sorry, I said 12, but I wrote 4. 3 times 4, which is 12. 2 times negative 2 is negative 4, and then negative 11. Putting all that together, I think you get negative 35 as your answer. Alright, we're going to finish with a difference quotient problem. The difference quotient is shown here below. And again, this is a formula that has a significance in calculus when you get there next year. And being able to evaluate something like this is important. The very hardest and trickiest part of this problem is the very first thing, but we just did an example of that. So if you can evaluate f of x plus h, then you should be able to evaluate the difference quotient. Let's go through it. So my function rule is up there above. If I ask you to do f of x plus h, here's what it's going to look like. 2 times x plus h squared plus x plus h. Right? So there my input has been plugged into the function, and I get that. Then I'm going to subtract. I'm going to put this in brackets because I'm subtracting 2 terms here, but 2x squared plus x is what's being subtracted, and I'm going to divide this whole thing by h. So while this is really complicated looking, it turns out that quite a few things end up canceling. So let's keep going with this. 2 times x squared plus 2xh plus h squared plus x plus h minus 2x squared minus x all over h is what I get in the next step. Distributing gives me 2x squared plus 4xh plus 2h squared plus x plus h minus 2x squared minus x all over h. Right, a lot to keep track of, but once I have that, you should start to notice some interesting things happening. You have a 2x squared and a minus 2x squared that cancel. You have a positive x and a negative x that cancel. And in your remaining terms, which are these 3 terms, you have a common factor of h. So I'm going to pull the h out. I'm going to write down what's left, 4x plus 2h plus 1, make sure there's a placeholder when you factor an h out, divided by h, and these h's end up canceling, and you get a final answer that's simplified, which is 4x plus 2h plus 1. So you had a few of these on your summer assignment. I know everybody had a tough time the first time around, but we're revisiting this so that you can know how to evaluate a difference quotient. Alright, let's finish up with the u-try. Different function this time. We would like you to evaluate the same expression, this time for a different rule. Give this one a try. Alright, so the work here for your answer is as follows. Again, remember you're plugging in x plus h as an input value, and then you've just got a lot of algebraic simplification to do. Final answer was 2x plus 4. Hold the phone. I just realized that I forgot a term. Remember that a binomial squared has 3 parts to it, so I should have a plus h squared there, which means that when I factor, I actually have a plus h in this spot. So my bad, I forgot that. Your final answer should have a plus h as well. Let's tack that on. Plus h. So that is your final answer.